Welcome to the course on operations management. Uh, Today we are going to discuss about module 7, that is inventory management. Myself Saurabh Majumdar, assistant professor, Department of Applied Science and Humanities, section Mechanical Engineering, Guru Nanak Institute of Technology under the aegis of JIS Group, 157 by F, Nilganj Road, Panihati, Shodhpur, Kolkata. So what do you mean by inventory? So inventory is defined as usable but idle resources, that is anything of value which is not in use at present but is expected to be used in the near future. That will be defined as an inventory. Okay, so like examples are like raw material, it may be finished part or assemblies, or it may be semi-finished goods, it may be finished goods, consumable, which are used for other products, tools and spare parts. Now come to next slide. So why do we carry inventory? That is, what is the need of this inventory? To maintain a smooth flow of the production systems, inventory is necessary. To take care of fluctuations in demand, inventory is very much useful. To avail quality discounts, obviously inventory is required. To create a stock in anticipation of rising the prices, inventory is required. Okay, now come to the next slide. For two types of systems that are required to place an order, like first one is the Q systems and second one is the P systems. Q system can be defined as a fixed quantity systems. Okay, fixed quantity system means that is quantity ordered per order is fixed, but time period between two consecutive order is not fixed. That will be called the Q system or fixed quantity system, where the quantity is fixed but the time between the two order, that is not fixed. But for P system, time between the placement of consecutive order is fixed, but quantity is varying. Quantity is not fixed. All the EOQ model, EOQ is the basic model for inventory management. Okay, so this EOQ model follow the Q system of ordering. That is where the quantity, number of quantity is fixed, but the period it is not fixed. Come to the next slide. So inventory management cost. So there is lot of cost are there, like opportunity cost, space cost, material handling cost, cost of insurance, cost of spoilage, deterioration, theft, etc., general administration cost. All these costs, they are associated with the inventory carrying cost. All these 6 costs, it will be under the ICC, that is inventory carrying cost. And this inventory carrying cost, it is directly proportional to the number of quantity, that is proportional to the Q. Q is the quantity, that is demand, annual demand. Okay, if demand is increasing, then inventory carrying cost will be increased. So if I show by a graph, it will be like this. So in the x-axis represented the order quantity Q, and y-axis is the annual cost, and it will follow a straight line. Carrying cost follows straight line. Why? Because it is directly proportional to the Q. So that's why it will follow a straight line. Now I will add another cost, that is procurement cost or ordering cost. So this cost is required whenever I am placing the order. So that's why it is called ordering cost or procurement cost, PC. But this ordering cost, it will be inversely proportional to the order quantity. So whenever order quantity is large, ordering cost should be low. Okay, so that's why it will follow a curve path. It will not a straight line, and you can see that whenever order quantity is large, ordering cost is gradually decreasing in trend. Okay, now come to the total cost. So total cost TC, that will be equal to the inventory carrying cost plus ordering cost. It is summation of these two, and if I put this total cost in our curve, you can see that this top curve, this will be the total cost. This will express the total cost. So this is the total cost, and this point, that will show the minimum total cost. This point, if I express the dotted line indication on the y-axis, this will indicate the minimum total cost. Okay, and in the order of quantity, if I drop down into the x-axis, this quantity is the optimum order quantity where the total cost is minimum. This optimum order quantity is known as EOQ, that is economic order quantity. Okay, so what is EOQ? EOQ is defined as the optimum quantity for which the total inventory management cost, total inventory cost is minimized, as we have seen in the last slide also. Now there should be some assumptions to for this EOQ model, and this EOQ model can be also known as Wilson model or basic model for inventory management. And there is some assumptions, that is total 7 assumptions are there to carry forward this model. The first assumption is constant rate of demand or consumption. So that is consumption is constant. Second is constant lead time. Lead time is constant. So what is lead time? Lead time is the time between the placing of order and the getting the order. Time between these two is the lead time. That is whenever I am placing the order and whenever I will receive the order. Between these two time is known as lead time. That lead time will be constant. In instantaneous replacement of stock. Then fixed price per unit. Then fixed procurement cost per order. Inventory carrying cost vary directly and linearly with the size of inventory. So inventory carrying cost is varying, it is not fixed, and it is directly and linearly with the size of inventory. That it will depend on the size of the inventory and no shortage. So these are the 7 assumptions. So if I put in the curve, you can see that is y-axis represented the time, and that is x-axis represented the time, and y-axis represented the quantity. And you can see that from this is the starting point. So it will start from Q quantity, and whenever time goes on, the quantity is gradually decreasing. It will come to 0. Again it will reach the Q. Again gradually goes on and come to 0. Again it will get the same quantity. So in that way it will carry on, and this will there, this is looks like a that is sawtooth, so that's why it is also known as saw-toothed curve. SAW, saw-toothed curve. Sawtooth curve. Okay, so it looks like the saw, tooth of the saw, hacksaw. And you can see that in these cases the LT is the lead time. Lead time is the whenever I am placing, so whenever the Q becomes 0, I am placing the order. Okay, and this much time will take to receive the order, so that's why this is expressing the lead time. Okay, that is LT. But generally it is not happen in the EOQ model. So we are placing the order just before the empty stock. Okay, I am calculating that. So it will start from here. Whenever our this is the quantity, whenever quantity Q reach to this quantity, we are placing the order. Okay, then what happen, whenever it will reach at here, we will get the full quantity Q. In that way it will carry on. And this duration is known as LT, that is lead time. So here and this point is known as reorder point. Okay, reorder level. Okay, now come to this some basic assumptions, like suppose we assume that annual demand is A and our order per order is Q. Okay, and carrying cost is expressed by C suffix C, that is carrying cost, and procurement cost or ordering cost can be expressed by CP. So number of order per year, annual demand is A and order quantity is Q, so number of orders should be A by Q. So A by Q is the number of order per year. So annual procurement cost, that will be the number of cost into CP. So that's why number of cost is A by Q into CP. That will be the total procurement cost per year. Now that is maximum inventory level is Q and minimum is 0, as you have seen here. So here it is Q and here it is 0. So what is the average? Average is Q plus 0 by 2, that is Q by 2. Q by 2 is the average inventory level. So what is the inventory carrying cost? That is average inventory level into, that is Q by 2 into CC, that is carrying cost per annum. Okay, so in that way we will calculate the total carrying cost. So this is my total procurement cost, this is my total carrying cost. So if I add these two, we will get the total annual total cost, ATC. That is the annual procurement cost plus annual inventory cost. You can see that this is the summation of these two. Okay, and APC, that is the annual procurement cost, which is inversely proportional to the demand, that is order, and but annual inventory carrying cost, which is proportional to the Q. Now you have to calculate the minimum value of this ATC, that is annual total cost. What is the minimum value? To calculate the minimum value, so here in this cases, what I see that this C value is constant, CP is constant, CC is constant, annual demand is also constant. Okay, all are constant. Only varying quantity is Q, that is A, CP, CC, all are constant. All are constant value. Only varying quantity is Q. Q is only varying. So you have to derivate this ATC with respect to Q and make it 0. Okay. To calculate the minimum value of ATC, you have to derivate this ATC with respect to Q. So whenever you derivate this with respect to Q, so you can see that this is the derivative which is shown here. Okay. And at last, what we get, that this is the value of Q. So Q equals to root over of 2a Cp by Cc. Okay, this is the value of Q at which we got minimum total cost, and this value is known as EOQ, that is economic order quantity, root over 2a Cp by Cc. Okay, and whenever you place this this value of Q at here, you will get the total minimum total inventory total cost, that is A. In place of Q you have to place this, that is root over of 2a Cp by Cc plus it is 1 by 2 Q. Q means root over 2a Cp by Cc into Cc. Okay, and if you replace all these things, you will get, that is A cancel out, so C will come up, that is root over of A Cc by 2 Cp plus, and here it will be again root over of A Cp, Cc cancel out, and this root 2 cancel out, so 2 Cc, so that will become this is the twice of this. Okay, so twice of this, 2 root over of I hope I will make mistake. So there will be Cp is missing here, so Cp is missing here, so I have to erase some part. I have to erase this part. Okay, and Cp, so 1 by root 2, and it will become root over of A Cp Cc plus 1 by root 2 root over of A Cp Cc. Okay, now it is right. So there is twice, so that means you have to add this 2, so it will become twice, 2 into 1 by root 2 root over of A CP CC. So ultimately final equation it will become root over of 2A CP CC. So this is the expression of minimum ATC, minimum value of annual total cost, that is root over of 2A CP CC. Okay. Now come to an example. This is an example where you can find that a material A is used uniformly throughout the year. The data about annual requirement, ordering cost and holding cost are given below. Like annual requirement is 2400 unit, ordering cost is 10 rupees per order, holding cost is 0.3 rupees per unit per year. Okay, so this is my annual requirement, that is this is the value of A. Okay, this is the value of A, and this is the ordering cost. Okay, so ordering cost, that is procurement cost, that is CP, and this is the holding cost or carrying cost, so this is nothing but CC. You have to determine the EOQ, that is economic order quantity, then annual procurement cost and annual holding cost. So EOQ directly you can put, that is root over of 2A CP by CC. So you put all the values, 2 into A, the value of A demand or requirement is 2400 into 10 by 0.3, you will get the 400. So this is the our economic order quantity value. Then APC, that is annual procurement cost, which you know that A by Q into CP. So put all this value and you will get 60 per year, and annual holding cost AHC is the Q by 2 into CC or carrying cost, that will be 60 per year. Okay, so in that way you will calculate the EOQ, APC, and if you want to find out the total cost, so total cost that also can be find out. So total cost, total annual cost, that is ATC. ATC equals to, that is APC plus AHC. APC is 60 plus 60, that is 120. That is 120 per year. So 120 rupees per year, this is the total annual cost per year. Okay, in that way you can calculate. So today up to this, and thank you everyone. Next class I will discuss about other different types of model for inventory management, like ABC analysis, VED analysis, FS analysis. Okay, all these types of model I will discuss in the next class. So thank you everyone. Thank you.